Hi, this is Jeff Spencer, Math 120 instructor for the Community College of Denver, and this is a video over rates and proportions, which is really the kind of second part of 6.2. So this is really kind of my 6.2 part 2 video, and I just wanted to go specifically over rates and proportion type examples and problems. So a rate is typically given as a unit rate, and a lot of us actually have experience with unit rates throughout our lives. So when we say a unit rate, like for example, when I give $12 per hour, it's telling you how much money you get per 1 hour. So the unit meaning one of the second unit. It's always a number of things, number of dollars that you get per hour. Most people, when you work an hourly job, your pay rate per hour. It's not you get $35 every 3 hours or something like that. So when we mean a unit rate, we just mean per something, per one of something else. Another example, when you're driving in your car, you'll see the speed is mph, miles per hour. They always give that per 1 hour, so it doesn't tell you how many miles you're going to travel in 90 minutes or 3 hours or 7 hours. It tells you how many miles you would travel in 1 hour if you kept up that average rate of speed. Another example we'll see here is like at the grocery store, you'll see usually like a unit rate cost. So this will be 45 cents or $0.45, which is 45 cents per ounce, something like that. So that's what we mean by unit rate. So to compute a unit rate, you simply divide the two values. The order that you divide gives the type of rate. So for example, if you can buy 300 pounds of sand for $65, then you can give 2 unit rates. It just depends on the order that you divide the two numbers. So if you take the pounds, the 300 pounds, and divide by 65, just to show the result here, just to show the rounding, if you divide that by 65, you're giving a number of pounds because you took pounds and divided by dollars. So this tells you that if I rounded to the nearest tenth here, 4.6 pounds per dollar. That's what we mean by unit rate, per $1. If you divided the number of dollars by the number of pounds, so if you did 65 divided by 300, this would give you the number of dollars per pound. And when I'm giving money answers, I need to round to the second decimal place. That's how many cents there are. So whenever I round to the second decimal place, I'm looking at the third spot, and the third spot tells me what to do with the second decimal. In this case, since this is 5 through 9, we round up, and that's why I gave this as 22 cents per pound, or $0.22 per pound. So typically, when you're given, my particular preference is that when you're given amount of something that you can buy and the cost of it, I definitely prefer the cost per unit type of rate versus the unit per dollar kind of rate. So this one I think is an easier one to understand. This is the one that you'll see at the grocery store. If you look at various price tags, you'll see in the little corner, it'll give you the cost per unit, depending on if it's ounces, pounds, grams, what have you. Okay, so that's just basic rate information. So a proportion, we're going to be solving various proportions, and a proportion is when you set two rates equal to each other. So when two rates are equal, they are quote-unquote proportional. So we solve proportions by the technique called cross multiplication, which I'll show when I do these examples here. And actually, I showed that was the last example in my 6.2 part 1 video, where I had 3 numbers up here and an x, and I was solving for one of those values. So, and I'm going to do that method here too. So let's go back to this 300 pounds of sand for $65. If you can get 300 pounds of sand for $65, then how much sand can you buy for $100? So if you know what you're doing with rates, you actually don't need to solve this using a proportion. For instance, if I know that I get 4.6 pounds per dollar, then if I want to know how much I can get for $100, I would just multiply that by 100. But you really have to know the ins and outs of rates to be able to know that. So if you're not comfortable with that, then you just set up a proportion. And the techniques for proportions are pretty straightforward. It's a much easier way to solve this problem if you're not super experienced with rates. So what you can do is when we give you the first ratio, it's 300 pounds of sand for $65. So I'll just take the same order, 300 pounds, $65. All right. Then it says, how much sand can you buy for $100? Well, then the $100, since I have $65 down here, I keep dollars on the bottom, so 100 down there, and then X is the number of pounds that I get for $100. So this is the three numbers that I know, and I'm trying to figure out the number of pounds that I can get for $100. So it's pounds to dollars, pounds to dollars. So I keep the units in the same spot, the matching units. So then I want to solve this, all right? And I'm just going to do the shortcut now. Cross multiplication just means that you take the upper left-hand corner times the lower right-hand corner, and the lower left times the upper right. So it would be 300 times 100 equals 65x, and then I divide by 65. What the shortcut is what you do is you look at the corners not involving x, you multiply those two numbers, so 300 times 100, and then you divide by the other number. So divided by 65 tells us that we would get 461, and I'll round this to the nearest tenth, 461.5 pounds. So 461.5 pounds. And you can write the word pounds too, I just abbreviate it like that. Okay? So then next, if a certain type of vegetable costs 22 cents per pound, then how many pounds can you buy for $5? Once again, if you know what you're doing with rates, if you have experience with this, there is a shortcut to this. You could just take 5 and divide it by 0.22. But if you're not familiar with that, let's just use the proportion. Okay, so what's our first rate? It's 22 cents or $22, so 0.22 for $1. Or sorry, for 1 pound. So 22 cents, so dollars or money, cents on the top, pounds on the bottom. So now I have $5 up here, and I want to know how many pounds I can get for that $5. So I have money, pounds, money, pounds. Money on the top, pounds on the bottom, and now I'm going to do cross multiplication. So what do? I start with the corner that doesn't involve x, the two corners that don't involve x. I multiply by those two numbers, and then I divide by the third number. So this is going to be 1 times 5, which is just 5, divided by 0.22. And it's 20, what am I getting this in pounds, right? Okay, so I'll just round to the nearest tenth again. So since this is a 2, I keep that the same. So this is going to be 22.7 pounds. All right, next. As of August 16th, I looked this up earlier today. As of August 16th, 2020, Colorado has 53,176 reported coronavirus cases. The population of Colorado is 5.8 million. How many cases does Colorado have per 1 million people? So this is what we call a per capita rate, so that we can compare the number of cases in Colorado, the prevalence of the number of cases in a state like Colorado to a state like California or a different state. And the two states have drastically different populations. Colorado has 5.8 million people. A place like California has like I think it's over 30 million people or somewhere around there. So you can't just compare the raw numbers. You have to do a per capita comparison. So this whole thing, when I say how many cases does Colorado have per 1 million people, that's a per capita thing. So it gives a fair comparison to a fixed size group of people. So the way to do this here, well, I'm just going to take coronavirus cases, total coronavirus cases to total population. So upper left-hand corner, I got 53,176. That's the total number of coronavirus cases. 5.8 million, we have 5,800,000. And then the number of cases per 1 million, well, I don't know the number of cases, so that goes there. And then 1 million is a 1 with 6 zeros behind it. I'll just put the commas in there to make it easier to see. That's 1 million people. So then I'm going to cross multiply to solve this. So I'm going to do the corners not involving x, and then multiply those two numbers, and then divide by the third number. So I'm going to do 53,176 times 1 million. And I'm going to divide, that's scientific notation that you see in there, and then I'm going to divide by 5.8 million. And it says that Colorado has 9,168, well, I'm just going to call this cases, so I'm going to round to the nearest whole number. So 9,168, right? 9,168 cases per 1 million people. Okay, and just to show you the figure that's reported on the internet, the particular counter site that I used. So I computed this using a 5.8 million population approximation. I just looked it up on Google real quick. So I use this site to look at the number of coronavirus cases in each state. Notice it shows Colorado here, and I use this number here, and it shows here total cases per 1 million population. So that's a per capita number, and their number is 9,234, which is really close to mine, which just means that they're probably using maybe not exactly 5.8 million here. They might be using a more specific population figure that I just quick referenced this from Google. But that's how they do it. That's literally the math that's done to get a number like this. And so then you can compare more accurately, say Colorado has 9,000 cases per 1 million people, and say California has more than that. And it's hard to do you want to look at the per capita for comparisons for groups of different sizes. So it's just a cool thing to show you that proportions are good for computing per capita statistics, which are good for comparing states and countries of different sizes, which we've been doing a lot recently with this pandemic. So that's it. We'll see you next time.